The science behind black holes. What happens when you fall into one? Black holes are one of the most fascinating and enigmatic phenomena in the universe. Formed from the remnants of massive stars, these gravitational giants possess a pull so strong that not even light can escape. In astrophysics, they challenge our understanding of space, time, and the very fabric of reality. Imagine the experience of falling into a black hole. Time stretches, and the laws of physics seem to bend. As we delve into this captivating topic, we'll explore the mysteries surrounding black holes, from their formation to their impact on the cosmos, igniting your curiosity about the universe's most intriguing secrets. What is a black hole? A black hole is a region in space where gravity is so intense that nothing, not even light, can escape its grasp. Characterized by an event horizon, the boundary beyond which nothing can return, black holes are formed when massive stars exhaust their nuclear fuel and collapse under their own gravity. This collapse leads to the creation of a singularity, a point of infinite density at the center of the black hole. The unique properties of black holes challenge our understanding of physics, making them a crucial area of study in astrophysics as we seek to unravel the mysteries of the universe. The event horizon is the critical boundary surrounding a black hole, marking the point of no return. Once an object crosses this threshold, it cannot escape the black hole's gravitational pull. This boundary plays a crucial role in defining the black hole's structure, as it separates the observable universe from the mysterious interior. Crossing the event horizon has profound implications. Time and space behave differently, and the laws of physics as we know them begin to break down. For anything that ventures too close, the event horizon represents the ultimate fate, where escape becomes impossible and the journey into the unknown begins. Spaghettification is a fascinating phenomenon that occurs when an object falls into a black hole, experiencing extreme tidal forces. As the object approaches the black hole, the gravitational pull on its nearest side becomes significantly stronger than on its far side, causing it to stretch and compress. Imagine pulling on a piece of taffy. It elongates and thins out. This effect can be so intense that even a massive star can be stretched into a long, thin shape, resembling spaghetti. Spaghettification illustrates the extreme conditions near a black hole, showcasing the bizarre and often mind-bending nature of our universe. Time dilation is a fascinating concept that describes how gravity can affect the passage of time, particularly near a black hole. According to Einstein's theory of relativity, the stronger the gravitational field, the slower time moves relative to an outside observer. As an object approaches a black hole, time for that object appears to slow down dramatically. For instance, if an astronaut were to orbit a black hole, they might experience just a few minutes, while years could pass for someone far away. This mind-bending effect highlights the intricate relationship between gravity and time, revealing the extraordinary nature of our universe. What happens inside a black hole? The interior of a black hole remains one of the greatest mysteries in astrophysics. At its core lies the singularity, a point where density becomes infinite, and the known laws of physics break down. Current theories suggest that understanding this singularity requires concepts like quantum gravity, which seeks to unify general relativity and quantum mechanics. Additionally, the information paradox raises questions about what happens to information when it crosses the event horizon. Despite significant advancements, many unknowns persist, and ongoing research aims to unravel these complexities, pushing the boundaries of our understanding of the universe and the fundamental nature of reality. Black holes play a crucial role in the evolution of the cosmos, significantly influencing galaxy formation and development. Supermassive black holes, found at the centers of galaxies, can regulate star formation by emitting powerful jets that affect surrounding gas and dust. They also contribute to the life cycle of stars, as massive stars often end their lives in supernova explosions, leaving behind black holes that recycle matter back into the universe. Recent discoveries, such as the detection of gravitational waves from merging black holes, have profound implications for astrophysics, enhancing our understanding of cosmic events and the fundamental workings of the universe. In this video, we explored the captivating world of black holes, from their formation and characteristics to the intriguing experience of falling into one. We discussed concepts like the event horizon, spaghettification, and time dilation, highlighting their significance in our understanding of the universe. Black holes are not just cosmic oddities. They play a vital role in galaxy formation and the life cycle of stars. Understanding these phenomena is essential for modern science. If you enjoyed this journey into the cosmos, please subscribe, like, and share this video for more exciting content about the mysteries of the universe. Thank you for watching.